So good afternoon, and thank you for coming to this session on the Internet of Things. So what is this Internet of Things? Basically, in the most basic form, it is about objects or things getting connected. So they communicate together, and they communicate with the user, hopefully providing some value. Looking around, we might see, for instance, in the living room, that we have AV equipment that nowadays is connected. You got smart TV that you can watch YouTube on it, get weather information. Some have Skype. You get your AV receiver that will pop up a notification saying it needs an update. Going a bit broader, you see that in the living room, in the smart home, you have the lights, the blinds, the security equipment, or the heating, ventilation, everything gets connected. And in everyday life, we also nowadays are always connected. We have communication devices with a smartphone. Most of us have smartphones and tablets. We have fitness equipment like the Fitbit, so we carry them around all day long, and they collect our activity, they collect our sleep patterns. We have healthcare equipment. For instance, we can read blood pressure. And going even a step broader, we have the smart city, where in the end it is very similar. We have the lights that get controlled from a central place. We get big displays that will push messages to us. We get security camera, sensors that can give parking information and things like that. With the addition that instead of being just one person or one family, it's now a whole community. So there is a social aspect also adding to that. Now, looking at specifically one device, the Fitbit, we see that it has sensors, so it's collecting data. It has a small display, so it can give feedback to the user. It has a companion mobile app, where you can also visualize some data. I can check the steps I took today. I can control the device, like program the alarm clock for tomorrow. There's a website, where again, I can visualize data, maybe in a more advanced form, like I have historical data, a graph of the steps I took for the last months. And I can control the device through that website too. And for that, I need a user profile, so username, password to log in. Taking a look at another device, the Nest connected thermostat, same thing. It has sensors. It will read the temperature. It will detect presence in the home. It has a rotary dial, so the user can interact with it, and it has a display to give feedback. There is a companion mobile app to display information to control the thermostat. There's a website so that you can, again, have a dashboard and control the thermostat, and you need a username and password to log in. So looking at those devices, you see that they very much exist in their own silos. They are connected, but not interconnected, really. They live in their own little world, but they share commonalities. They collect data through sensors. They somehow process the data. They have some logic, some rules. They allow the user to visualize the data from mobile application or from websites, and they allow the user to control the device, again, mobile or website. Plus all the required things like user profile, security, logging, etc., etc., etc. So those manufacturers need to, each and every time, re-implement the building blocks to provide that basic plumbing, basic infrastructure. And it's not where their added value is. Their added value is just a small bits and pieces on top of that. And so if we can replace that with a common infrastructure, it means that they don't have to reinvent the wheel each and every time. It also means that now, instead of being only vertical in the different silos, we can go horizontal and have those devices really interconnected. So if somebody would want to have a go at implementing that common middleware, what would the problems be? First of all, we see that each and every device will have a different protocol. Hopefully the one I showed, the Nest, has now a developer program, so they will have a public API. The Philips Hue, the API is public. Same thing for the Fitbit. So hopefully there's a trend now that it's becoming a bit more open, but still, every time it's different. And then there are devices where it's just closed. So proprietary protocols, you can't do much. You need to reverse engineer, it takes a lot of time. There have been and there are some standardization efforts. So in the home automation field, you have like KNX, Z-Wave, ZigBee. But then, for instance, taking ZigBee, you still have within ZigBee different profiles. So it's not completely different protocol, but still many different profiles, many different standards to go after. And the market is quite, the distribution is quite expensive for all these devices. So this leads to what we call the industry vicious cycle, where the fact that there is no standardization means that when you want to integrate the devices together, the integration cost is very high, meaning that the complete solution is quite costly, and that the market for that is a niche market, a luxury market. And when you have a luxury market, that usually stays small, and the players in the market, they want to keep their market share, so they are not keen to open, meaning that it reinforces the fact that there is no standardization, etc., 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 and we arrive to a status quo deadlock, which, of course, is something we do not want. And we hope to have a solution. We think we have one. And the way it started is with open source. Why open source? Well, the first thing is, when you want to tackle a problem, you often go to what you know. It's, you take your experience with you. And OpenRemote was founded by Mark Fleury and Yoel Inforce, both from JBoss. Mark Fleury founded JBoss, and it was pretty successful. So JBoss is an application server in the Java enterprise world that was widely adopted from the developers, so the adoption was good, and from the business point of view, it was quite successful. In the end, JBoss was sold to Red Hat, so a nice pull-off there. And so they started going the same route for this field. The other thing, it's going open source is a proven and widely adopted way to do an infrastructure. I mean, we think about having Linux, Apache server, MySQL databases, all this infrastructure for internet websites, it's open source. The barrier to entry is very low. Basically, you can download the source code for free, so you can't do much cheaper than that. The cost of integration is low. Again, you can, instead of starting from scratch, you go download the software, and the basic parts are there. You just add whatever you need for your own needs and contribute back to the project. The knowledge acquisition costs, are quite low. And another point that isn't on the slide, but that was raised this morning during the keynote, is, of course, that we want to trust all this. And one way to trust is, if it's open, you can take a look at it. You know what's there. Everything, there is nothing hidden from you. But really the most important part of all this in open source is the community. It is, we think, very well tailored to the problem of having those multiple protocols. Because implementing a protocol for a device, for instance, might not make sense to a company from a business point of view, because there are not many users, and so on the balance sheet it just doesn't compute. But it's very likely that in a community you will find like-minded individuals that will just go after that one protocol that they want to have. And so the community will really grow the product and allow to tackle those different protocols. It's a bit the long tail way of doing things. We are quite lucky. We currently have about, in OpenRemote, 40,000 visitors per month on the website, and about 4,000 downloads a month. But most importantly, we've been growing those numbers on a year-by-year basis by about 80% each year for the last 3 years. So nearly doubling the community every year is really nice. And this is a quote from Matt Turk for TechCrunch, which says, talking about Internet of Things, whether the winning platforms are open or closed will play a huge role in the future of the space. My bet would be on openness, and our bet is also on openness, so we think that's a good way to go. So, open source. Next, adoption of standard, but we talk about standards. We don't want another proprietary standard that would be closed, that would be expensive to get to. I mean, we have in the field some specification that would cost you a few €1,000 just to get the specs. That's not the way a standard should be. We want a de facto standard, like HTTP or things like that, that just grow from the community. A standard that is open, that everybody can look at, everybody can freely implement. That is the way it should be done, and we think that having this kind of open standard is really superior to having a proprietary ones. And the last part of the equation is off-the-shelf hardware. If we want a solution to be widely adopted, we don't want to need to do custom hardware, often expensive, the kind of touch panel you see there on the wall. That's pretty dedicated, pretty expensive. We want a wide adoption. And we are pretty lucky, because these days, again, the smartphones, the tablets, we find products that are powerful and cheap. Things like the Raspberry Pi, again, a very powerful computer that is extremely affordable. And even in the more home automation field, if we wanted to take a look, we have Z-Wave devices or stuff like that that is not that expensive either. And when we have that in place, we think that now the circle is inverted, and we have a virtuous circle. That means that having open protocols leads to low cost of integration, leads to a overall solution that is cheaper, which means that the market gets much bigger. And when the market is big, the players tend to be open, and so now the circle reinforces itself, and we have an emerging ecosystem instead of the deadlock. And so open source, open standard, and off-the-shelf hardware, or even open source hardware, which is also very nice, is the basis for the OpenRemote solution. Now, what is OpenRemote really? That's a big picture of the whole OpenRemote ecosystem, so all the different components. The main component is the controller. The controller is the software that will talk to the different devices. It will speak their different protocols. It will run 24/7. It will get the information from the sensor and control the devices. In technical terms, it's implemented as a Java application, so it should run on a broad range of devices. Everywhere Java can run, we can run the controller. And this clearly means off-the-shelf hardware. Things like the Raspberry Pi, it runs on the Pi. It runs on NAS devices, so things like Synology, Netgear, QNAP. Recently at the CDI in the US, QNAP used OpenRemote as the basis for their OpenRemote, their home automation demo. In terms of the protocols we currently support, we have some of the big names in terms of home automation. So KNX, Z-Wave, Zigbee, Enotion, Backoff, things like that. For AV equipment, infrared, we support the Denon, the Marantz, the Onkyo receiver, but also we support the basic protocols, so TCP, UDP, HTTP, Telnet, which mean that anything that provides an API through that mean we can easily integrate with. And it doesn't have to be hardware, it can be software. So getting weather information from a weather service on the net through an HTTP interface is something that is very easy. And the role of the controller is really to be an integration platform so that you can, independently of the lower protocols, have the same view on it. So in this picture we can see that we have an IP backbone, we have maybe a KNX infrastructure to control the lights in the building, and we can add some wireless Z-Wave devices to that equation, but still on the top we integrate everything, and it's a unique vision on top of that. The controller can run standalone. It can act just like a bridge between protocol, or it can be automation with rules and trigger some things automatically, but most of the time we want a user interface. And so that's the role of what we call the console, which their role is simply to take some XML description of a UI and render that for the user. And so the user can now visualize information coming from the controller, so display the temperature readings in the room or something like that, and can control the orb, to the controller, and then eventually the devices. We do support the main culprits there, so iOS, Android, and web browser. So any modern web browser we can have an interface for. And we can do that from inside the LAN or from the outside your WAN. So this part is the runtime. That's what you use daily. But to configure the system, we have all the infrastructure, the backend in the cloud. The Online Designer is a cloud-based, web-based tool to do the configuration. And by configuration, we mean both the devices, so configure the fact that you have a KNX or, I don't know, weather information through HTML, and the UI. So the standard way to define UI with button images and sliders and web widgets and whatnot. And what's very important is that we make sure that these two activities can be done separately and are really split the responsibilities, so that somebody more technical can define the devices and somebody with more of a UX or UI expertise can define the user interface. And the last bit of the ecosystem here is Beehive, which is basically our storage or database thing, which means that everything you do configure in the controller gets pushed to Beehive, and then Beehive can push that to the controller. So that is a very quick overview of our infrastructure. Well, that's all nice, but that's technical. What can we do with it? Because in the end, for an end user, what matters is solutions, not technical stuff, not the platform. So I want to start with a first example. I want to briefly show a video of OpenRemote used in a more of a home automation or smart home environment with a typical, again, audio, video, lights, security kind of thing. So this is kind of a one-off or custom for each home, for each application. We also want to work in another similar field, but more for mass market. So what we are doing is having, in collaboration with ProDrive, which is an Eindhoven company, a full solution that is both software, because we are a software-only company, and or project, and hardware. So they provide customizable hardware. And so that utility companies can have a complete solution with the hardware, the software, the backend services to do things like smart metering or energy management. A different topic that people might not think about when looking at this type of platform is smart city, and more specifically community management. In 2011, there was the Glow Festival in Eindhoven. So the Glow Festival is an art exhibit throughout Eindhoven where you have different art exhibits that are arranged in a circuit around the city. It's quite popular, so it means that it attracts a lot of people in the city that go wandering by and then stop to look at something. And this might be not really an issue, but it becomes something to manage. And the idea of the city of Eindhoven is to see how, using smart technology, you could facilitate that and ease the whole crowd that going around the city. So the prototype that we did in collaboration with several other companies was that we took 2 spots on that circuit, and we did have cameras that were counting the people passing by. So we had an idea of the number of people that were gathered there. We also had a couple of microphones getting us the noise level. And there was also a mobile application that was provided by the organizers so that the visitors can get information on the art exhibit, but they can also vote. So they had a 0 to 5 hearts rating. And what we did was collect that information. And so we have the number of people, the sound level, and the liking of the visitors that is collected and displayed, but also that is passed on to rules. And the rules would decide of a lighting scene that could be applied on the spot, so that you could modify the lights in the street to see if that would change the behavior of the people that were there. And that's what the system does. It does, based on the values collected, propose a lighting mood to apply, and then it's up to the operator to really apply it or not. So that was a prototype nearly a couple of years ago. We are now moving to a full installation, again with the city of Eindhoven in Stradiumseind. So Stradiumseind is an area which can be quite active at times. It's, I don't know how many, 60 or 70 bars in a street. And so during a certain period of time, you have a lot of people that sometimes do not totally behave as they should. And again, they wanted to see how technology could ease all that. And so it's the same concept, cameras counting people, sound measurement in the area, around in the neighborhood, so we'll see how that would impact the neighborhood. A bit more information, also weather information. We collect all that, display that on a dashboard, also display historical data. And as this is a longer term project, we are now in collaboration with the university. It's the Living Labs project. They are studying all this data to again see how we can define rules that would control the lighting and influence the way people behave there. The last application I want to talk about today is social alert. So this is more in terms of healthcare or assisted living. More and more people that get a bit older or have disabilities still want to stay at home and still want to be able to live a happy life with their own independence. So the goal of the system there is that using a basic sensor in the home, like door contacts or presence detection, we can define basic rules that using the sensor will detect behavior of those people. Like if we see somebody going out at 2 a.m. and leaving the door open, we know that something might be wrong. And so the system will detect that and send a message to a caregiver or their family to say, hey, go check on the guy, maybe there's something that needs to be checked there. So I hope that this gives you an idea of the broad range of applications that could be tackled with this platform. Just very briefly, I want to talk about the business model, because one thing sometimes I get asked, or we get asked, is it's open source, you're giving away the software, I mean, how do you live? How do you make the money? And OpenRemote, as JBoss was, is professional open source. So it was thought out from the start with that model in mind. It means that there is a company behind the project. It got funding so that we didn't start a project with, we create a repository on SourceForge and there's nothing in there and just hope people will come. So there is something there to start with. We are also very careful in terms of licensing and in terms of code contribution to make it work. And since a year approximately, we have been pushing a bit more on the commercial aspect, and we now have 3 business propositions. So in addition to the open source project, which is still there, totally free, we now have professional designer, which is for one-off project, you have integrators or designers who want to have access to what we call the professional designer, which is like the free one, which with more tools so that it can streamline their process as professionals. We also target more the mass market, where manufacturers might want to bundle their devices with potential use with OpenRemote, which means that they can get cloud hosting designer with their own brand in there, maybe some specific protocol. And the last one is OEM, so device manufacturers that would want to include the OpenRemote platform inside their device. And so there we have dual licensing agreement to make sure we can cover that. So as a conclusion, again, I hope that you've seen that you can do many things with the platform, but in the end, it is just that. It's a tool, it's a platform. So hopefully you can join the community and make something great with that platform. To do that, it's pretty easy. You can go online, openremote.org, you download the controller, install it on your own hardware. It can be anything for now, your laptop or a Raspberry or anything you have lying around. Go online, create a free account on the designer. You can start there, configure your device, create a UI, and then go to the iOS App Store or the Google Play Store, or go to the forums and download the latest version of the console. And to give you a bit of inspiration, I've also prepared another video with some of the realization from our community members. See, this is from TAS, so it's a company. So in the community we have just do-it-yourself members, but also companies that are quite interested in that just contribute as community members. So quickly, so you can do something very, very quickly as a designer. This is again healthcare or assisted living. This is a person who has ALS disease, so is stuck in a wheelchair, and they made with eye tracking software, because we did for him to control his home and TV just by looking at the screen and blinking to control things. approach to designing a user interface is somebody wanted to have a really photorealistic UI. So it took photos of his office and mapped that to the live devices. So that when he touches the light on the screen, the light really goes on the office. Or if you open the window, it opens on the UI. So slightly advanced things. So thank you. I can take any question now. We also have a booth just down the hall, so if you want to step by, ask any questions, see some of the things I showed in the video are there, so you can have a live demo. The Stradun Design project is there too, and we can talk about anything there. So thank you again for listening. So any question now or?
So how long do you think before we will all find this in our home? Is this a matter of 5 years? And maybe some people even quicker, or is it 10? Or what do you think?
In terms of finding what this kind of system?
What, I mean, it becomes mainstream in a lot of people's homes.
I'm not sure. The thing is, the technology is there. Hopefully, the costs are coming down. You see things like, I mean, Nest. Still a bit expensive, but it's getting a bit more mainstream. We've been talking about home automation for really a long time, and I don't know exactly when it could come really be implemented. It's a different. I think it's a bit of a different story to know if people want to do it. There are things for which it's easier, like again a thermostat. You just replace the thermostat. There are things like your electricity. You're not going to redo your whole electricity just to have automation. So I think for people who want it, it's already now affordable and you can do something, but I'm not sure on the awareness of the public also when they will really want to go there.